Alright, so today we are going to do a Pearson square method. The goal of this video is to balance a beef ration using the Pearson square method. I deal with a lot of beef farmers in our area, and one of the main things that they are concerned about is making sure that their animals have adequate nutrition and have a balanced diet. So here's an easy way to do that. A couple objectives that we're going to have here is identifying the steps in balancing a ration, discussing the importance of feed analysis, because a feed analysis is a test that they get done on their feed, and it's important. Discuss how nutritional information is used, and develop balanced rations using this method. So, a couple of definitions. Nutrients obviously are important in animal lives just like they are in humans, and they are chemicals. They are anything like nutrients, proteins, carbohydrates, fats, minerals, and vitamins. Same thing that animals or that humans have. Nutrient requirements, though, are a little bit different because every animal is going to be a little bit different. A beef cow is going to have is going to need more nutrients than, say, a calf is going to. A lactating cow will need even more because they're feeding for two. So, nutrient composition is the amount of, or what that food is made up of. Alright, so a ration, when I say a ration, what is that? It's the total amount of feed an animal consumes in a 24-hour period. And a diet is the type of amount of feed an animal receives. So they're a little bit different, but very comparable. Alright, so the importance of feed analysis, it's important because we have, feed analysis is often done in a laboratory, and it tells how much digestibility is in the food. And so the more digestible it is, the more nutrients they're going to get. And so that's why it's important to be considered in this analysis. Alright, so we need to balance the ration. We need to determine nutrient needs. We need to determine feedstuffs, nutrient contents. We need to calculate the feed used in the ration, and then check those rations against the nutrients needed of the animal, and then determine the pounds of feed by a dry matter basis, which is how they calculate feed rations, but then the animal gets it on an as-fed basis, so we'll just have to convert that back over. So we can do that quickly. Alright, so first thing we have is we're going to, in this example, utilize a 500-pound beef calf that we want to gain 2 pounds a day. So this table right here, if you can see, it has 13.1 pounds of dry matter is what a 500-pound steer will gain, and they'll use 1.49 protein, and this TDN is total digestible nutrient. So it's basically what it will use in that feed, and that's 8.75 pounds or 67%. So that's what we're going to need right there. All right. So what feed stuff is this going to be? Well, we're going to use fescue, shelled corn, and soybean meal are the 3 feed stuffs that we're going to concentrate on today. Fescue is a forage which is needed for ruminant animals, 4-compartment stomachs. They utilize those. It has microbes in it, and those little bugs eat the forages up. They're not like humans. Shelled corn is going to give them some energy, and then soybean meal can be used as a supplement if our energy needs aren't met. So let's talk about this. Alright, so here's the example of the Pearson square. Obviously, it's a Pearson square. You can see the square here. What we do is we take the roughage, and we take 48%. We need 67.5% for this ration. Okay, that's what it said in the table. So we take shelled corn, which has 90, and fescue, which has 48%, and then we subtract and make an X out of it. So we've got 22.5 parts fescue, and then we have 19 parts corn. So total parts in this ration is 42. So we'll need that. That number will then need to be divided by that 22.5 parts and that 19.5 parts that were from this previous square. Okay? That will give us the percent fescue and corn based on the energy. Okay? So we got 54% and 46%. We're going to use that together, all right, to determine our crude protein, because that's very important as well. We need energy and protein. That's what we're balancing our ration for. So what we do is we know that the beef animal, based on that table, needs 11.4% of crude protein. So will this fescue and corn reach that? Well, we take 54 or 0.54 times 9.5, which is what the fescue has in it, and that equals 5.1%. Then the corn we used is 44.46, and then we multiply that by 10.1, which is their energy requirements in corn, and that is, or excuse me, the protein in corn, and that's 4.6%. That only equals up to 9.7. So the animal needs 11.4. What do? That's where soybean meal comes in. So soybean meal, we plug this 11.4, which is the requirement that it needs. We do the same thing again. We subtract, and we got 38.5 and 1.7 parts. So this is the mix. This 9.7, we found it previously, okay? So we're plugging that in there. And 1.7 and 38.5. So that's going to give us a total part of 40.2. So we're going to do the same exact thing. 38.5 is the amount that it had, divided by 40.2, which is our total parts from this Pearson square, and then 1.7 divided by 40.2. And that's going to give us 95% in the mixture, and then 42% in the mixture, okay? Or 4.2. So we'll need to have 4.2 of soybean meal. So how many pounds is that? We got the balanced ration. How many pounds is that? So we take 13.1 pounds of feed, which was in that table that said that's how much the animal is going to eat a day, and times 0.042, which was how much that was, the soybean meal. And the reason we're starting to calculate the pounds of dry matter in the soybean meal is because that's the least supplement. So it goes in the order of least to most. So 0.4042 is 0.55 pounds of soybean meal. Okay, that's the only amount that you're going to need of soybean meal. So once again, that's just a supplement. All right, so what do we need in the other mixture? Well, we got to break it down again. So we remember that 13.1 pounds is how much the calf will eat, minus the 0.55 pounds of soybean meal. That leaves us with 12.5 of available dry matter left. So in that fescue, we went back to that first table, okay, the first Pearson square that we did, and rounded up to 0.54, and multiplied that to get by the 12.55 available to get 6.77 pounds of dry matter. And the same thing for corn, only we just subtracted the fescue, so we've got 5.78 pounds of corn. So converting it back to as fed, because that's what the animal gets, divide by the dry matter ingredient in it. So we found that these dry matter ingredients were in the table for the nutrient requirements. And so we take 6.77 and the 0.95, so we just found that in the table, okay, the percent dry matter it had, and that's going to be 7.35 pounds. Then the shelled corn is 5.78, which gives divided by 0.88, and that's 6.55, and the same thing for the soybean meal, and that's 0.67. So there you go. Our energy and our protein nutrients are met and balanced, and we know that we have to feed this many pounds in order to get that for our beef animal. Now, some resources. That's just a quick flyby, but some resources if you want to sit down and actually do this on your own feed, you can do that. The website, there's New Mexico State University, University of Kentucky has a balanced ration information. That's actually where I got this example from. And any kind of Agripedia or your extension services will have resources available for you to do that. So I hope this makes sense to you, and I look forward to seeing some of your all's examples.